Imagine having your own vocal AI assistant that can understand any document that you throw in and allows you to find the most relevant parts of the document based on the text or chat that you are trying to do, and instantly starts to answer the questions that you're passing in entirely running vocally on your own machine. In this video, you're going to learn how you can build such RAG applications using entirely open source software and the free model DeepSeek-R1. Hey everyone, my name is Vedelin, and in this video we're going to have a look at how you can build a completely vocal RAG application using DeepSeek-R1, Ollama, LangChain, and Streamlit. We're going to have a look at how you can build the complete pipeline for ingesting files, how you can create your chatbot and integrate everything within a Streamlit UI application. But why would you need to build a complete RAG application when you can use something from my previous video? Well, if you have tried the application from the previous video, you see that when you're passing longer files, for example, files that are 3, 4, 5 or more pages, you see that the LLM gets easily mixed up with the whole information or textual informations from the files, and the answers doesn't get good, and you don't get good answers from the LLM. One way to combat this and get better results is to split the documents within parts or chunks, and based on those chunks find the best ones that are relevant to the current question that the user have, and based on that provide the information to the LLM, and the LLM will use this much more relevant information to give you better answers. This is a high-level overview of how our application is going to work, and you can see that our application has two main components. One is going to be the file ingestion, and the other one is going to be the chatbot. The job of the file ingestion is to get our documents that we're going to upload and chunk them and prepare them for usage with our chatbot right here. And the job of the chatbot is to essentially get the context from the files, pass it to a large language model. In our case, this is going to be the DeepSeek-R1 DSTU model, and then also add a chat history that is the recent history of the conversation that the user and the AI assistant is having. And then based on that, provide us with an answer or a response to our user. So how the ingestion pipeline is going to work is to be split into different subsections or steps. The first one is going to be to create chunks for each document. In our case, we are going to be using a very simple chunker, which is going to essentially split the documents into 2048 characters of chunks. And then we are going to enhance our chunks with some contextual information. This is going to be very similar to what the Anthropic team introduced during the contextual retriever video that I also did. And then from here, we're going to do two things. First, we're going to create a semantic retriever. In this case, we're going to be using embeddings in order to create this retriever. And then we're going to be enhancing our approach to building the retriever by introducing BM25 retriever, which is a rough estimate or a rough concept of using keyword search based on the documents that we have. So we have those two different retrievers, something that is called hybrid approach or hybrid search approach. And based on that, we're going to be building this ensemble retriever, which of course is going to combine those two. Based on that, we are going to be providing some results for the context from the user query, and those results are going to be re-ranked or reordered by our reranker. And this information is going to be passed into the LLM that we're going to be using, DeepSeek-R1, along with the current chat history that we have. And based on everything that we are passing into the LLM is going to respond to the user. If you want to get access to the source code along with the complete bootcamp that is available on ML Expert, please subscribe to ML Expert Pro. Also, we're going to start live sessions between 7th and 9th of this month, that is February. Within these 3 days, we're going to cover the short version of this schedule right here. We're going to go through what production-ready machine learning engineering means. Then we're going to have a look at the foundations of LLM. And finally, we're going to have a look at how to build real-world applications, in our case, chatbots, RAG applications, agentic systems, and finally, we're going to be running a complete LLM fine-tuning experiment. So if you want to support my work and join the bootcamp, consider subscribing to ML Expert Pro. Thank you. This is the project opened up in my Visual Studio Code, and in order to run this project, you need to have Ollama already installed, and you need to be able to or downloaded the DeepSeek-R1 distill model. So if you don't know how to do this, please go to one of my previous videos where I show you how to install Ollama locally. Other than that, the project structure is pretty simple. You see that we have dependencies within the pipe project. And here you can see that we have LangChain as a dependencies. Also, I'm using a LangChain Ollama extension. LangGraph, I'm going to show you why we need this. Ollama, then FlashRank, FastEmbed, PyPDFM in order to ingest the PDF files, rank BM25 for the implementation of the BM25 algorithm, and then the latest version of the Streamlit library. So here we have the app.py, which essentially is our UI code with the Streamlit application, but the main code of this application is going to be within the CogVault subfolder. And here you can see that we have file loader. This should be pretty self-explanatory. A config file. Let me show you what it contains. It contains a configuration of what files are allowed or their extensions. The model that we're going to be using, DeepSeek-R1 14 billion parameter model. Then the temperature. Also, this is all of the configuration for the chunking or the pre-processing of the files. The number of results that we're going to return as a context to the chatbot, and then some path configuration. Let me continue with the file loader since it is pretty straightforward. Here we have a data file or data class that we are going to be using as a file. This file has a name and the content of the file is going to be a string. Here I have two functions, one of which is to get the PDF content on given bytes, and this will just return the string of the PDF. Then I have the word uploaded file. This is going to be passing in an uploaded file from Streamlit, and here we are going to process the information from that file, and depending on whether or not this is a PDF file, we're going to handle it as a PDF file. Otherwise, we're going to essentially get the string content of the file and just return the file. The next and probably the most important file within our project is the data ingester. Here we're going to be creating the whole pipeline for processing the files that the user is uploading. And this has just a single public function called ingest files. And this is going to take a list of files and return a base retriever that is a retriever from LangChain. Let me show you how this file works and what we are doing under the hood. The first thing that I'm doing here is to create a list of documents based on the files that we're processing. Those documents are coming from an import from LangChain, and I'm going to be passing in the content of the file, and then within the metadata, I want to preserve the name of the file. This will be some sort of ID of the original file. And then I'm going to convert the documents into a list of chunks. And in order to do that, I'm going to be calling this create chunks function. And here you see that I'm using a text splitter, which actually is a recursive character text splitter that is coming from LangChain. And I have the configuration of the chunk size and some overlap, which is 128, as you can see right here. Based on that, I want to split the documents within the provided document that is. And if I'm not using contextualized chunks, I'm going to simply return the chunks from the text splitter. So why contextualize chunks and how this all works? Well, this was produced or introduced by Anthropic, and they said essentially, well, sometimes if you can have a bit more context about the file chunks that you're providing to your LLMs, maybe your LLMs are going to be even better when doing the answering within your RAG applications. And in order to do that, you need to simply prepend the context of the complete document that you're passing along with the chunk of the text. So this is what we're going to do here. I'm going to create an LLM. In our case, our LLM is going to be one used for pre-processing. And intentionally, I'm using a very weak LLM. I'm going to be using the Ollama 3.2 3 billion parameter model, which I'm going to essentially say, well, here is the document, here is the chunk text, and create me some context for this document and this chunk. And I'm going to essentially prepend this before the chunk content and create a document for that. So how all of this works, let's go to the generate context function. This is pretty simple. I'm going to be using a prompt that I'm going to pass in the format messages function. And here I'm going to be passing the document and the chunk text. And then based on that, I'm going to invoke the LLM, which again is a completely local instance thanks to the chat Ollama, and return the text for the context. Let me show you how simple is the actual prompt for the contextualization. You're an expert in document analysis. Your task is to provide brief, relevant context for a chunk of text from a given document. And here you see that we're passing in the document and the chunk. And here are some rules that are going to be essentially following our guidelines that we need in order to get the chunk and the context for the chunk. You see that we want the context to be relatively small, 2 to 3 sentences, and to give us a feeling of what the complete document is all about. So this in practice helps very much when building RAG applications to have better contextual informations when your chunks are returned to the LLM that you're using. And based on that, we're going to be essentially creating these contextual chunks. Let me show you. After those chunks are created, we're going to continue by creating an in-memory vector store. Here, you can use the database or vector database that you like the most. In practice, I'm using in production systems mostly pgvector. I also like Quadrant and Miush, if I recall correctly. Those, in my experience, are very good. I also like the SQLite extension for smaller projects. Of course, Ollama and the LangChain library provide a lot of usage for different vector stores, and choose the one that works best for you. In my case, I just want to have this in-memory vector store, and I want to create the documents based on the chunks that I'm providing, along with the embeddings that I'm going to be using. Now for the embeddings themselves, I'm using the fast embeddings library, and this is the PG small English model that we're going to be using just for these embeddings. Of course, if you're using a more powerful model, probably your semantic search is going to be much better compared to what we have here. But for local instances, I found that this model works quite well and it is quite fast. So I'm going to be using this in our case. And I want this retriever to return the five top results based on the query that the user is having. And then we're going to initialize the BM25 retriever. So what is BM25? In essence, this is a search engine kind of algorithm where you essentially are providing some keywords, and based on those keywords, the algorithm is returning the most relevant information. This is very different and very fulfilling for building a hybrid approach to the search or the retrieval part of your RAG. And when you do this, essentially on one side you're using the semantic search with the embeddings, and the other side we're using essentially a more classical approach that just looks at the words, their occurrences, and based on that computes how likely is that a given document or chunk in our case is relevant to the user query. And then we are combining all of this with this ensemble retriever. And in this case, I want the weights to be 60% from the semantic retriever and 40% from the BM25 retriever. And on top of that, I'm using my own reranker, of course, using a pre-built model, which essentially is going to be doing the final sorting or a ranking of the results that are provided from the ensemble retriever. And this works quite well in practice, since I would argue that the final re-ranking step is pretty important, since I'm cutting off only the 3 top chunks that should be the most relevant for our case. And let me show you the re-ranker that we're going to be using. Again, I'm going to be using Flash re-rank library. This by default, again, returns only 3 results. And the model itself is MS Macro Mini LM. I found that, again, this model is quite fast, works quite well on local instances, but it is mostly doing a good job with English documents. So if you are looking at more multilingual re-rankers and embeddings, probably you should try to do your research and have a look at which models would work best in your particular use case. The next important file that we're going to have a look at is the chatbot.py. And here you'll see that we're defining this chatbot class. Here, this class wants as an input the list of files that we're going to be using as our context. And you see here that this chatbot internally is calling our ingest files function and creating this retriever. Also, I'm creating the main LLM, which is going to be the DeepSeek-R1 model that we're going to be using for the chat of our application. And then I'm also keeping a list of the files along with this create workflow function. Let me show you what this function does under the hood. So here you can see that we are building a state graph, something that is coming from the LangGraph library, which allows you to build those chatbots in much easier way compared to what we had before with chaining of chains within LangChain. At least in my opinion, this is much better approach. And here you see that we are passing in this state class. Let me show you what we have as a state. We have a typed dictionary that contains the question, the list of messages that we have thus far for this chat, the list of documents, which is going to be the context for our LLM, and then the answer that the chatbot is going to provide for us. So this is the state that we have. And based on that, we're going to be building this state graph, which has a sequence of functions that is going to call, or methods in our case. First is going to call our retrieve, which is going to call our retriever with the query that we are passing in from the user. And based on that is going to be building our context, that is going to be the list of documents that or chunks that we're going to return to the LLM. And then it is going to call the generate method. Here you see that we're essentially populating this prompt template with the question, the documents, and we're going to format those into strings. And finally, we're going to be passing in the chat history. So based on those messages, I'm going to be invoking the LLMs. In our case, this is going to be the DeepSeek-R1 model. And I'm going to be passing in the answer of this invocation to our state. So what the format docs does in our case, this is essentially using the file template from the previous video. I'm going to be formatting the name of the file and the content. This is going to be essentially be this XML template with the file name and the content for the file. And after this is done, I want to have a single function. Let me show you. That is going to be the public function called ask. And in this function, I'm going to be essentially using events. This is going to be calling this internal function called ask model. And the ask model method is going to be the bread and butter. Pretty much everything is happening here. So the first thing that we're going to do is to get a list of messages that the UI application is going to give us and convert those messages into messages that are of the type of the LangChain use case. And then we have a payload, which payload is going to contain the prompt from the user along with the history that we are passing in. And then for the workflow itself, I want to stream the responses, and I'm going to be passing in the payload, the config, and then I want the stream mode to be both for the updates and the messages. This is where I'm essentially returning also the messages and the context or the sources that we want in order to show the user from what information the chatbot read through. And here, let's see the event type. If it is messages, I'm going to be returning this chunk event, which is going to contain the chunk of text or string that the model is going to be providing to the UI application. And if this is an update and this is a retrieve update, I'm going to get the context that was retrieved from our retrieval pipeline and yield a sources event. Otherwise, if this is a generate event, this is going to contain the final or the complete answer within the state of our graph. And I'm going to essentially yield a final answer event that I'm going to show you how I'm going to be using here. When this final answer event is provided, I'm going to be removing the thinking part from the response of the DeepSeek model. Then I'm going to be adding to the history the user prompt, and then I'm going to be adding the assistant prompt without the thinking part. So this will make sure that our history is completely preserved and the user can ask his or her next questions, and the bot is going to know what was the previous conversation all about. These are the prompts that we're going to be using. As you can see, those are quite simple. We have a system prompt. You're having a conversation with a user about excerpts of their files. Try to be helpful and answer their questions. If you don't know the answer, say that you don't know and try to ask clarifying questions. And here for the prompt itself, here's the information here about the excerpts of the files. I'm going to pass in the context. One file can have multiple excerpts. Please respond to the query below. And this is the prompt template that is going to be the chat prompt template from the LangChain library. We're going to essentially build the order of the messages. First, we're always going to start with the system prompt. Then we're going to insert the chat history. And finally, we're going to add the human or the current query for the user. And based on that, we're going to be building the list of the messages. We still have a row of user and assistant. This is more for our UI part of the application, along with the message. And the events that we have are quite simple. We have the chunk event, then we have the sources event, and then the final answer event as well. All of those are going to be data classes. The final part of our application is going to be the UI component that is provided by Streamlit. And here you can see that we have a list of loading messages, a welcome message, and then I'm configuring the page along with the title and the subtitle of the application. The first more important part right here is that I am going to be creating the chatbot using a list of uploaded files. And the uploaded files itself, I'm going to be creating with the ST or Streamlit file uploader. Here I'm specifying that I want PDF, Markdown, and text files, and I can upload multiple files at once. So if those files are not uploaded, we're going to be presenting this warning. And after the documents are uploaded, I'm going to essentially return every file that we have uploaded. And based on that, I'm going to be creating this chatbot with the this function right here. Also, this cache resource will allow us to remember the chatbot that we have built, and this chatbot is not going to be refreshed during running this instance of the Streamlit application. After that, if we don't have messages, I'm going to be calling the create history function, which is going to be essentially returning a list of our welcome message at the start. And in the sidebar, I'm going to be showing the files that we have uploaded from the chatbot, nothing really major. Then I'm going to be essentially showing all of the messages for the history of our chat. And after that, I'm going to be adding the chat input from the user. Then this is essentially how I'm going to handle the chat responses. Here you see that I'm going through the chatbot ask function or method, and I'm passing in the prompt along with the message history that we have thus far. And if the event is sources event, I'm going to be showing the list of the sources. Otherwise, I'm going to be filling in this message placeholder while I'm accumulating the complete response that you can see right here. And based on that, I'm going to be filling the text also with the sources from this app. To test our rack application, I'm going to be passing in the text of this very nice blog post by Anthropic, building effective agents. And you can see that this contains a lot of text, and I have tried to get the markdown into the previous application that we built, and the LM gotten mixed up with so much text. Let's see how our rack application is going to handle this blog post. Let me start by uploading the markdown file for the blog post. And let's start with a question. What is the difference between agents and workflows? And you can see that the model is starting with the thinking part, and this is something very specific to the DeepSeek-R1. And this is the final response. You can see that it is quite long. In this case, we have the complete thinking along with the answer. What is the difference between workflows and agents? And you can see that we have the complete markdown with the chunks that we are also providing. And let's continue with our next question. Which one is more useful in practice? And you can see that it starts with, so I'm trying to figure out whether agents or workflows are more useful in practice. So it knows that the current conversation that we're having is about what is the difference between workflows and agents. And it says essentially that both approaches can be used depending on the use case, and gave us use cases for the workflows and agents, and a nice conclusion based on that. Also, we have the sources within the blog post. So this is it for this video. We've seen how we can build a complete vocal RAG application that uses DeepSeek-R1, Ollama, LangChain, and Streamlit. We've tried out the project with a relatively long markdown file, and we were able to talk about the different points within the blog post. So if you want to extend this application or try something else, I would suggest that you start with the pre-processing. Maybe you should try to increase the chunking size and try to have a look at whether or not the responses are even better compared to what we've seen right here. There is definitely room for improvement, but this is one pretty practical and real-world use case of the RAG pipeline that you can use with the hybrid approach for BM25 and within the semantic retrieval that we also built. Thank you for watching, guys. Please like, share, and subscribe. If you want to get access to the complete source code for the GitHub repository for the project and get access to the complete bootcamp with the live sessions that are coming on February 7th to 9th within ML Expert Pro, please subscribe. I'm going to link the bootcamp and the subscription process in the video down below. Thank you for watching, and I'll see you in the next one. Bye.